Hey everybody. So today we're going to be replacing this standard all-electric water heater with two traditional heating elements with this higher efficiency hybrid water heater that has two heating elements and a refrigeration circuit at the top that runs in reverse, blows cool air out the exhaust. So this thing is advertised to save quite a bit of money. Energy Guide estimated yearly operating costs are $117 for this unit. If you can see that down there, that label down there. The one that I'm replacing, I can see just the side of the label right back here. This says $561 a year. So quite a bit of savings if it all pans out. The biggest challenge of this install is going to be the space constraints. I don't know if you guys can tell, but that water heater is kind of wedged back in there between a refrigerator and a wall on two other sides, leaving only one exposed side. And the way this water heater is situated, if you look at it, you have on the bottom, you have your cold water inlet down here. You have your hot water outlet up on the left right here. You have your thermal pressure relief valve. You have your condensate drain. You got your little control panel here, but you also have the exhaust off to the right. So this thing needs like, I don't know, like what is that, like 120 degrees of open space? I mean, you could say I could just turn this thing to the wall, you know, maybe like that to make this vent blow out more, but then I don't have enough space because the inlet is going to be right up against the wall. So I think what I'm going to do is I'm going to take some time offline to figure out how I can just rearrange this whole area. Like I might be able to move that fridge over to where the water heater is, and then maybe put the water heater where the fridge is or something along those lines. I'll figure something out off camera and I'll let you know what I decide to do. All right, I did some rearranging. I ended up moving this central vacuum cleaner up. It was mounted much lower on the wall. I wanted to be able to have enough clearance down here where I could fit my sandblasting cabinet right where I'm standing right now. I think I'm going to keep the water heater where it is. You can see I moved the fridge over here. It may stay there. I'm not really sure yet. But I think the next step is to get this water heater out of here and see how things line up. So let me get my drain set up. I have one of those battery-powered Harbor Freight water pumps. I'll show you that in a second. Okay, I've got the water shut off to the hot water heater, both the hot and the cold side. I have the hot water heater unplugged, because this one does still work. So it's completely isolated from a plumbing and electrical perspective. Got my Harbor Freight battery-powered water pump down here. It does come with an AC adapter. If you don't have one of these batteries, I'm going to see if this battery can pump out the water heater. So first step is to open the drain valve down there. That's a better look at the setup. So I just cracked this ball valve here with a screwdriver. You got a coupler here. That clear hose comes with the pump. Goes to the outlet side of the pump right here. And I have the garden hose. I'm sorry, the inlet side of the pump, and the outlet side of the pump is going to a garden hose that goes under my garage door. So let's turn this thing on. And let's time it. So it's 1:05 p.m. Didn't seem to like that. I do have it plumbed right? Yep, I do. Let's try again. There we go. Had to pop open the thermal pressure relief valve. So I'll let that run for a while. Didn't run for very long. I don't think enough air was getting through the thermal pressure relief valve, so I just unhooked the cold water line from the water heater. Let's try that again. There we go. 106. Let's see how long it takes. She's pumping at a pretty good clip. Hopefully you can see that. And that's about it, folks. 1:18, so just over 10 minutes. And the battery is still at 3 bars. You guys probably can't see that because of the stupid light, but 3 bars. Not bad. Impressive, Harbor Freight. All right, let's get this thing out of here. Not hooked up to anything anymore. Pretty light too, as you might expect. Oh, it's always fun trying to get a job done using hardware store parts. I had originally planned on using these stainless steel lines, which is kind of like my go-to when I do water heaters, but unfortunately I couldn't find any threaded 90 adapters that were lead-free at Lowe's. Go figure. So instead of using those, you just got to be agile sometimes and be able to pivot. I'm going to move over, instead of using those stainless steel lines, I'm going to use PEX. So I got one of these, or a couple of these PEX 90s that should thread right on here, like so, and we'll use those down there and up here. And I got a couple sticks of PEX that will go from the hard pipe, which is, I'm going to terminate right about there or so, and up here or so, to those PEX adapters. So let me get that started. There's not much for you guys to see here, but I'll show you the end result. First step is to disassemble all this plumbing up here. Oddly, these 2 ball valves were leaking, which is kind of unusual for ball valves, so we're going to replace those. I'm going to remove this ground strap from both sides. Take off this compression fitting. This goes to the fridge. A lot better than the saddle valve. The local hardware store also didn't have these parts, which is wonderful. This is a specialized piece up here, so we're probably going to have to reuse it unless you want to do something mail order, which I don't really feel like doing. I'm going to take off these plastic scutcheon plates here because the torch will melt them. They're just these little split ring ones. Great for installation after the fact. All right, now we can take our torch and start disassembling all this stuff. So I'm going to get an old wrench. I got my MAP gas torch, and I got a old adjustable wrench here. Let's take this side. Let's take the cold side off apart first. Let's keep our ground out of the way as much as we can. Got to boil off all the water. Solder is already melting. Oh, they're good and tight. My goodness, there we go. Do the same thing on the hot water side. Although this time we have to be a little careful not to burn this wood here because we have the ball valve right up against the wood. This valve's already leaking, so I don't need to go too nuts trying to save it. There we go. Whoa, that was close. Dunk this one in the water too. So now we have our hot and cold size completely virgin, and we can do what we want to them now. Okay, I got this vertical section just kind of test fitted. Gonna do a 90 down there, obviously not taped together, it's just to hold it for now. Just want to get those lengths correct. I'm gonna move the hot water heater back into position and just kind of get that bottom horizontal, cut to the right length. Okay, I got the cold side all soldered in. Got a PEX to 3/4 inch copper sweat adapter, a 3/4 inch ball valve, a 45, a 90. Got it blocked off here just for some support. I'm gonna add another support right at this 45. It's a little loosey-goosey there. I got the top piece sweated as well with the scutcheon back. I do need to finish off the portion above this ball valve for the fridges, but I'm probably gonna do that tomorrow because it's getting kind of late. Let's plumb in the hot side now, because that's really what matters here for a hot water heater, right? All right, I'm almost done with the plumbing. I have all the valves plumbed in. I still need to brace the hot water pipe, but it's actually pretty solid because I braced it in the wall off camera. It was a little loosey-goosey, and it's pretty solid now. So now, I think we need to turn the water on, just make sure there's no leaks anywhere. All right, all the valve handles are horizontal. We should be good to test. Let me go turn the water on to the house, and we'll see what happens. If it does leak, you guys will be the first to see it. Just make sure you yell, all right? See anything spraying anywhere? I don't see anything. Don't see any leaks. Let's run a dry finger over all the joints. Don't see anything. So far, so good. All right, so now I'm going to drain just some water out of the pipes because it's probably pretty nasty with all the solder and, you know, copper little spriggles. And so yeah, I'm going to run maybe a gallon of water out of each side. Okay, got all the pipes secured, top and bottom. Everything is rock solid. Kind of nice. So now I think it's time to get the water heater in place, and we'll use our PEX clamps, hopefully, to get this thing fastened. This is my second video installing one of these water heaters, which is why I'm kind of flying through it. That plus it's late. A couple of you pointed out that there's a code violation installing a shutoff valve on the hot side. You're probably right, but I install them anyway because I like to be able to isolate the water heater completely and remove it without shutting off water to the house. And that's really the only way you can do it, by installing a water shutoff valve there. What you can do to mitigate any risk is you can take the handle off and just mount that somewhere else. This way someone who's meddling around that doesn't know any better won't turn that handle. The reason why it's a code violation is because if you shut this valve down here and the cold water supply, completely isolating the water in the tank, and the tank is powered on and heating, the tank can essentially become a bomb because there's nowhere for the water to expand to. So in theory, the thermal pressure relief valve right here should open and vent the tank, but you know, that's just belt and suspenders. That's the way code is for you. So again, it's a code violation to have that shutoff valve there, but what I'll do is I'll take a crescent wrench, I'll just take that handle off and leave it somewhere else where only I know where it is. This way, the only way to isolate, or only way to shut off the water to the water heater is on the cold side. Okay, I got my PEX clamps on. I am far from an expert in using PEX. This is probably my third time doing it, so if I did anything wrong and it leaks, you guys will see it first. So I did clamp, and then a clamp here, and then in the back you can't see. Let's put some water in it and see what happens. Let's see, so first we gotta open here. No obvious leaks so far. Let's open the hot water side. I got the thermal pressure relief valve open just to vent all the air. Let this fill for a little bit. Okay, time to make some electrical connections. I am going to reuse the power cord from my old water heater because it worked just fine. Looks like it came with, or I guess the new water heater has a 1/2 inch knockout, so I'm going to knock this out to 3/4, which is the cable clamp on my old unit here. Okay, that's all hooked up. Now deep inside of here, there is a ground screw, and on this power cord, there is an eyelet for the ground here. So yours might be a little bit different, but this is what mine is. I'm going to go undo the ground screw in there and sneak this eyelet on top of that. Okay, that's all done. Now we're going to hook our wires up here. Doesn't matter what color goes to where. This is 240 volts, so it doesn't really matter. Probably should be using a bigger wire nut, but we'll see how it goes. All right, that's good. Now it's really important that you not rush this last step. So you might be tempted to just turn on the power right away. And you know, you can, but you gotta make sure that this water heater is filled with water. If you do not fill it with water, you can damage the heating elements in here. It's what they call a dry fire. Bad things can happen. So let's make sure all of our wires are snug. We should be able to plug it in now. See if we tuck all these wires back inside. It's pretty cramped in here. I'm not exactly sure how I'm gonna get all these wires in here. There's a lot of them. Let's plug it in and see if everything's okay first before we go nuts with that. 1, 2, 3, contact. Our screen is booting up. It says disabled. I'm trying to remember, I think you just changed the mode, right? Let's do on maybe? There we go. Let's do mode. Energy saver. She's running. I hear the compressor running. I feel cool air coming out. That's good. Very nice. Let's get this thing going on Wi-Fi. So I said to press and hold this. Or maybe not. Okay, I guess it's in Wi-Fi mode. Okay, it's searching for the device. I had to turn mobile data off. I'm going to do connect. All right, it's the next day. I realized I haven't shown you guys how to do a solder joint. Got pretty far in this job and didn't really get that done. So I'm just going to give you an example on a piece of 1/2 inch copper here. Most important thing is for it to be clean. So I'm going to use one of these little spinny pipe brush thingies that can clean both male and female ends. So I'm just spinning it around. And that's sized for 1/2 inch copper right there. And they also have one here for 3/4. Spin it around really good. Should be nice and shiny like that. Hopefully you can see that. Then what you're going to want to do is you're going to want to use some flux. I use Harris Stay Clean Flux. Links in the description for this stuff. And Harris Stay Bright 8 solder. This is very expensive to use for just general purpose plumbing, but I use it for HVAC too, so kind of serves double duty. So I've already prepped the joint on this side here. So let's go ahead and we'll just solder this one really quick. I'm going to stick this brush on the other end to keep this pipe from rotating. Something like that. So I'll show you this one, and all the ones that I've done already are literally no different than this. So you always want to think about where your solder is going to flow. So notice that this pipe is pitched very slightly that way, so any excess solder will drip that way, not into this end right here, or not into this end right here, which I still need to solder. That'll make things more difficult if that's the case. So let's get going. We'll just flip it around just to make it more obvious that this side's pointed up. I'm going to light my MAP gas torch. Just a old Burns-O-Matic. We're going to heat the joint. I'm going to focus most of your heat on the fitting, not the pipe itself. Try to get good coverage all the way around. I like to heat from the bottom because then all the heat will then, when you put your solder on the top, you'll know when it's hot enough. And it is. You see how it's just melting in just like that. One more heat. When it drips out the bottom, you know it's done. That's it, folks. Just let it cool down now. Once the fitting is cool, just take a damp rag and clean it up. And that's what your finished solder joint looks like. I try to make it so those bubbles are at the back. This one's going to be mounted like this. You won't see that bubble. Made a little bit of progress since I last hit record. So I got the fridge water line secured to the wall, and I did a compression union into the plastic fridge water. And the plastic line goes like all the way to the front. It was very inaccessible, and I didn't feel like taking the whole fridge apart. So I just ran copper that you see there, 1/4 inch copper, to a 1/4 inch compression union, and I just unioned into the plastic fridge water line. So no big deal. Did a drain right here. So I'm coming out of the water heater with a 3/4 inch threaded nipple, short section, vertical T, 90, 45, there's a 45 in the back and a 90 back in that corner there. And for now, just have the pipe just kicking into a bucket here. I'd have to drill a hole in the side of the house all the way over there, which is going to be fun because it's solid concrete. But that's my problem, not yours. I do have the ball valve for the fridge water lines there, so that vertical one is going to my kitchen fridge right there. This one is coming out the side and going to the fridge off to the left over here. So that's where we're at right now. Water heater's been running great. I had hot water this morning, took a shower, so yeah, making progress. So I think still have to run the thermal pressure relief line. Debating how I really want to do that. I mean, I might just use shark bites because, I mean, that thing in reality should never really be exercised. But sometimes they do seep, so I might just do a shark bite out the thermal pressure relief valve down there, and maybe a shark bite in that center port in the wall that's untacked, maybe a 90. I don't know, I'll figure something out. Okay, so I got the remaining section of this condensate drain run through the side of the house here. I ended up using my Bosch rotary hammer to just drill a hole just off the corner there, and I used a heat gun. I don't know if you can see that bend, but there's a very slight bend to it right here. I used a heat gun to mold this bend just to kind of let it hug the wall, as you can see here, and I strapped it in here. It's got a downward slope, as you can see, so we should be good there. Trying to think what else. Yeah, still need to do the thermal pressure relief valve. Really don't want to do that. While I still have everything apart, I thought I would stick a current clamp on this thing just to see how much current it draws. So it's running now. I just set the water temperature artificially high to 125. And if you look at the current clamp, it is drawing 1.59 amps. So about 1.6 amps. For reference, the old electric water heater that I took out of here, when it was running full bore, it was drawing about 19.4 amps. So drastic difference here. Granted, this thing will run longer because the heating elements don't heat, or the heating elements heat faster than the compressor does, but this is what, 1/10 of the current roughly? So pretty cool. I know this is a little bit sketchy, but I didn't have the materials on hand, and neither did the local hardware store, to do this thermal pressure relief valve properly. I wanted to vent it to that middle hole in the wall that was for the thermal pressure relief valve on the old water heater, but just don't have the materials. So what I did is I ran some hard copper just down onto the floor. I don't have a floor drain. I can't create one very easily, so this is just temporary until I can get the right materials to go up in through that center outlet. So is what it is. This will last until the parts arrive. I think that's going to be a wrap, though. You can see the install, top to bottom, left to right. Again, that's exiting out into a flower bed in the front of the house, which should be fine. I mean, this thing doesn't generate a lot of condensate. I did install one of these at my mom's house last year, so if you want like a step-by-step, more detailed installation, probably check out that video. I'll leave a link in a pinned comment. I kind of flew by on this one because I was without hot water, and obviously I've done this before. So yeah, I think we're going to call it a wrap. If you like this video, please subscribe. Stay safe. Thanks for watching, everybody. Take care.